Alright, in this section 7.5, we're going to talk about exponential and logarithmic equations. We've got two objectives. We're going to learn how to convert between exponential and log forms. We've already talked about that a little bit. And some other applications of exponential and logarithmic equations. So let's go on. We have, this is the exponential form, x is equal a to the y, and y equal log base a of x, are equivalent statements. And so you need to be able to go back and forth between exponential form on the left and logarithmic form on the right. The inverse of the function f of x is equals a to the x is log base a of x, and vice versa. And we've got log base a of a to the x equals x, then a log base a of x equals x. Log of 1 is always 0 because anything to the 0 power is 1. And log base a of a, remember when the bases match, the exponent is the answer. And so in this case that you see right here, the bases match, the exponent is 1. And so log base a of a is 1. If it was a squared, the answer would be 2. Okay, so let's go to the next slide. Here's some more. We've got the sum. If you've got a product, you can separate it into a sum. Log of x times y is log of x plus log of y. X divided by y is the same as log of x minus the log of y. So a quotient can be separated into a difference or a subtraction problem. And log of x to the r power, you can bring that power in front, and it's r log base a of x. We've done this already. This is just sort of a reminder of some of these rules. And you're going to use all of these things to solve these equations. Now what you need to notice about here is the word log is not here anywhere. And we can't get a common base. We've got a base of 3 here, and we've got 11 here. And there's no, I can't make 11, 3 squared is 9, 3 cubed is 27. So I can't get 3 to some power to be 11. So you're going to end up taking the logarithm of both sides. Now you can use the ln or you can use the log, log. It really doesn't matter. But what you're going to do is you're going to take the natural or common log of both sides. So we're going to do here the natural log of 3 to the 2x minus 5 equals the natural log of 11. Now that exponent, 2x minus 5, is going to end up coming in front, like the exponent rule says. And so you have 2x minus 5 times the natural log of 3 equals the natural log of 11. Now you're going to divide by the natural log of 3. And that will give you a number when you put it in your calculator. Okay? Then you'll subtract 2. Just moving things around like you would typically to solve an equation. And you can do this and get a number. You don't have to leave it like this. You can go ahead and get a number. And then you'll divide by -5 in order to get your final answer. And so what I would do here, rather than writing it all out necessarily, I would get a number answer for this. And then take that and divide by -5. And that'll give you your x value. Okay? And so your exact answer will be a decimal. Well, this is the exact answer, excuse me. Just like this is the exact answer. But we're going to ask you to round it to a decimal, 2 or 3 decimal places. Okay? So here they used, you took the log of both sides. Now, let me just show you what they've done, because they kind of don't show it. From here, what was done was you had 2 minus 5x and times the log of 3. The log base 3 of 3. Well, remember, when the bases match, this all of that equals 1. So 2 minus 5x times 1 is just your 2 minus 5x. So that's how they get this. And then they take the log base 3 of 11. And now they're going to... Okay. Now you're going to have the change of base formula on the right, that the log base 3 of 11 is the same as the natural log of 11 over the natural log of 3. Or you could say log base 10 of 11 over log 10. And that equals 2 minus 5x. So on the right, that generates a number answer. You'll subtract 2 again, and then you'll add 2, divide by -5. And so you still end up algebraically with the same answer, doing it either way. I like the first way better, personally. Okay. Alright, so now we're going to go... you have to remove the variable from the exponent, which you get by converting to log form. So let's look at some other examples. Okay, go on. Key step to finding the exact answer is to remove the variable from the exponent, which is achieved by converting to log form. In other words, the variable in the exponent goes to the front when you convert it to log form. Decimal approximation, you have to change the base to something the calculator will do, which is generally base E or base 10. Okay, so now you're going to just divide that out because we've got natural log, and you should be able to get -0.037. Now I would recommend that you try this in the calculator. Like I said, I like to get that before in the other slide. I like to get the number answer before I divide by the -5. I think it's easier than trying to enter this whole thing in the calculator. But you need to practice getting these numbers in the calculator to be sure that you do them right. What you probably need to do to enter it in the calculator, just as a caution, if you do wait to this step, is you're going to have, excuse me, negative natural log 11. Then you'll hit your division button. Then you need to put parentheses 5 natural log of 3, and some of your calculators will put a parentheses in there already when you hit the natural log button. Okay. Then you can say plus 2 divided by 5 and then enter. And that should give you that answer. But you have to be sure you put your denominator here, this part, all in parentheses, because if you don't, it's going to divide by 5 and then multiply by the natural log of 3. So unless you tell it, and you might even put this in parentheses just to be sure. It's sometimes entering in the calculator is a tricky thing. So you have to learn how to do that. You don't want to have done all the work right and have the calculator give you the wrong answer. So be sure you practice a little bit with this. Okay, now we've got this equation. Again, there's no way we can get a common base, so take the log of both sides. So it would be 3x minus 1, log or natural log, either one of 5, equals x plus 3, natural log or log of 2. So, again, taking the both sides, they're going to use common log, which is log. It doesn't matter, though, and they states it there. It doesn't matter. So here we go. Take the log of both sides, then bring the exponents in front. Now this problem's a little trickier because there's more to it. You're going to have to distribute the log 5 to the 3x and the 1, and distribute the log 2 to the x and the 3. So that looks like this. 3x log 5 minus log 5 equals x log 2 plus 3 log 2. So what they've done, in case you have trouble seeing it, is they've taken the log 5 and multiplied it by the 3x, and then again by the -1. It's like we tend to forget that the distributive property, the number that you're distributing can be behind the parentheses. We're used to seeing them in front. So hopefully but they've taken the log 2 and the log 5 and multiplied it by each thing that's in parentheses. And so you end up with this long statement. Now what you have to do is get anything with an X in it to one side of the equal sign, and anything that doesn't have an X in it to the other side of the equal sign. So that'll be the next step. So now we have 3x log 5 minus x log 2 equals 3 log 2 plus log 5. Now we're going to have to get an x, factor out an x, because we want to solve for x. So on the left side, we're going to factor out an x. And so that becomes x times, parentheses, quantity, 3 log 5 minus log 2. And that is still equals 3 log 2 plus log 5. We haven't really done anything on the right. Now, to get x by itself, we divide by all of this. That's going to be what we divide by. Now, if you want to, you could go ahead and get number answers for these before you ever start. You could go ahead and get a decimal approximation for this, and you could get a decimal approximation for both of those quantities and then divide them. And it's probably easier, again, than entering the whole law of the log business all at once. But the exact answer has the word log in there. It's going to be the division problem. So let's look at our exact answer, which is that. Then you have to enter 3 log 2 plus log 5. And again, when you enter it in the calculator, be sure you put this in parentheses, the numerator and the denominator in parentheses, or it's only going to divide by just a few things and it's going to end up not being a right answer. So be sure you group the whole numerator in parentheses, hit the division symbol, group the whole denominator in parentheses, and then hit enter. And again, practice to be sure you can get the right answer. And then our decimal approximation is 0.892. Okay. All right, now what they've done here, just so you see, they've taken the 3 up to, this is the same as the log of 2 cubed, bringing the 3 up as an exponent. This is 5 cubed. Okay, so that becomes the log of 8 plus the log of 5 equals the log of 125 minus the log of 2. Now, you could take, because this is a plus, you could multiply your 8 and your 5 and see it become the log of 40. And because this is a division, or minus, it's a division, so that could be the log of 125 divided by 2. And so you can do those, simplify those things more if you want to. Okay, which we just talked about doing that. So your exact answer can take a lot of different forms, but your decimal answer is going to be approximated to 2 or 3 decimal places, whatever they ask for. All right, now here we have the word log on one side of the equation. When you don't see the word log at all, you're either going to have to match the bases or take the log of both sides. When the bases can't match, like the previous problems, you take the log of both sides. Here we have the word log once, so what you're going to do here is change it to an exponential form. And we already should know how to do that. Our base is 7, our exponent is 2, and it equals 3x minus 2. So we're going to write, again, we're going to put it in exponential form, which is going to become 3x minus 2 equals 7 squared. 7 squared we know is 49. Then it becomes an easy problem to solve. 49, we add 2 across, that becomes 51. And then we divide by 3, so x is 17. Okay. Here we have log base 5 everywhere. We can combine this into a quotient. And so it will become log base 5 of 2x plus 3 over 2x minus 3. And it equals log base 5 of x. When you have log I'll write it over here. Hopefully it won't interfere. Log of some, I'll say 5 of A. It could be any base. Log base 5 of B. If the bases match, then in this case A equals B. And so that's what we're going to basically try to do with these. We're going to have we're going to have log equals log, and then the arguments will equal each other. So let's look at this. So we're going to write that as a quotient, like I said, because of the minus sign there. And then x is equal to 2x plus 3 over 2x minus 3. Simple as that. Now you can multiply by 2x minus 3 on both sides. Makes it cancel out on the right. Distribute your x, so you have 2x squared minus 3x. And then you're going to bring the 2x and the 3 from the right side to the left side. So you're going to have minus 5x minus 3. Now, when we have a situation like this, we've got a quadratic, and so you factor to solve it if you can factor. If you can't factor it, you use quadratic formula. So we're going to factor this as 2x plus 1 times x minus 3. So our solutions, remember, we set each factor equal to 0. So it'll be negative 1/2 and positive 3. Now I'm going to remind you again, because this is something that a lot of students struggle with, how to factor this. So remember, what you do is you come up with your two numbers. We multiply 2 times negative 3, first and last number, and that equals negative 6. And our middle term is negative 5. I need two numbers that will multiply to be negative 6 and add to be negative 5. But this sign tells me that the two numbers have different signs. When the second sign is negative, the signs of my two numbers are different. So I'm going to have a minus 6 and a plus 1 are the two numbers that I'm going to use to add to be negative 5 and multiply to be negative 6. And so then you rewrite your equation, 2x squared minus 6x plus x minus 3. I just take that middle term, the minus 5x, and instead of that, write the negative 6x plus x. Now I group, factor out the greatest common factor from each group, so I factor out 2x here equals x minus 3. When I can't factor out anything, I go ahead and put a 1 out there as a placeholder, times x minus 3. And then remember, your two factors, one of the factors is the numbers in front, so you have 2x plus 1. And the other factor is what's already in parentheses. And you can see that that is the same thing that they got right there. Okay. So if you were not sure how they got to those, that's how they got to them. Okay. So this is the part that we have to be careful of. We do have to make sure that none of the answers end up with us trying to take the log of a negative number, because we cannot take the log of a negative number. So when you have solutions in log problems, you need to double check them. And so in this case, when you put the negative 1/2 in there, we end up with negative 1 plus 3, which is okay. But we can't take the log of x is log of negative 1/2. We can't take the log of a negative number. So the part that's red tells me 1/2 can't be used. And so then you're going to check 3, and that one's okay. It doesn't get us trying to take the log of a negative number. So even though we got two answers, the only solution we can use is x equals 3. So be sure you check your numbers. If you're getting something wrong, it may be that you haven't checked and one of your solutions doesn't work. Okay, here is a word problem, compound interest. Saving up money for a down payment on a new car. She has $5,500, but she knows she can get a loan at a lower interest rate if she can put down $6,000. She invests $5,500 in a money market that earns annual rate of 4.8% compounded monthly. How long will it take that to grow to $6,000? So we're going to solve it for t, which is one of the letters in the variables in the exponents of a compound interest formula. So here's the compound interest formula. A is equal to P, so we have 6,000 equals 500. 1 plus R over N, since it's monthly, the compounds are 12, raised to the NT power, so that's where the 12T comes from. Now the first thing you're going to do is divide by the 5,500. Okay. And then you're going to get a number for the 1 plus 0.048 over 12. And they carry everything out. They don't ever get an answer for anything. But you can get number answers for these, so that you're not working with all this extra. Go ahead and divide the 6,000 by the 5,500. Get a number answer. Just don't round it too close. Carry it out to 3 or 4 or 5 decimal places so you don't have a rounding error. So anyway, what we've done now, you can see we're going to bring the 12t in front. We're going to bring our exponent in front and multiply that by the natural log. And in this case, they have gone ahead and combined the part on the right, and that comes out to be 1.004. Okay, so we want to solve for t, so we have to divide by the 12 and the natural log of 1.004 to get t by itself. Okay, and then you just solve this out, and you get 1.82 years, because t is always in years. Okay, so not quite 2 years, 1 year and 10 months almost, for the 5,500 to grow to 6,000. Radioactive decay, we have this formula given to us. We know A sub 0 is the initial carbon-14, AT is the mass remaining after T years, natural E, the exponent E raised to this power times T. If they want to know the half-life, okay, so we're looking for the value of T for which A sub T is half of A0 or A0 over 2. So A0 over 2 is equal to A0E raised to that power. Okay, A0 over 2 divided by A0 is 1/2. Then you take the log of both sides, and when you bring that exponent in front, you have the 0.000121t times the natural log of e, and then that's 1. That's why the natural log symbol went away on the right. Natural log of 1/2 divided by negative 0.000121, and you're going to get 5,728 years. Okay. Now we're going to put this number back in the formula and do both sides by 2.3. Find how long it takes, and it's 3,533 years. Okay. That's how you would age date a fossil. That's the end of this section.